The problem is from GATE 2017 mathematics paper, question number 4. The problem given is, if the series summation n equal to minus infinity to plus infinity, an times z minus 2 whole to the power of n is the Lorentz series of the function f of z as z to the power of 4 plus z cube plus z square divided by z minus 2 whole cube, where z belongs to C minus the singleton set 2. Then a minus 2 equals. So it is asked that the coefficient of the term z minus 2 whole power of minus 2 in the Lorentz series expansion of this function. That is nothing but the term a minus 2. So the NPTEL reference to solve this problem is Module 6, Lecture 3. The title of this lecture is Essential Singularity and Introduction to Lorentz series of complex analysis topic. This lecture is by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. You can watch this reference video using this YouTube link. So now coming to the solution. Given that f of z is z to the power of 4 plus z cube plus z square divided by z minus 2 whole square whole cube, and that is nothing but the Lorentz series summation n equal to minus infinity to plus infinity an times z minus 2 whole square for z in complex plane minus the singleton set 2. So it is asked to calculate the value of the term a minus 2, that is the coefficient of the term z minus 2 whole square. Sorry, here it is n, z minus 2 whole power of minus 2 in the Lorentz series expansion. Expansion of f of z about the point z equal to 2. So by just looking at this problem, you can easily observe what it is asked to calculate is the term a minus 2. For that, we have to write the Lorentz series expansion of this function about the point z equal to 2. So from this function, we can easily see that the denominator is already in terms of about the point z equal to 2. But coming to the numerator, it is given a polynomial about z equal to 0. So for that, to calculate the Lorentz series about z equal to 2, we have to convert the numerator about the point z equal to 2. That means wherever the term z appears, we have to write that as z minus 2. So that follows in the following way. So the given function is z power of 4 plus z cube plus z square divided by z minus 2 whole square. Sorry, whole cube. As you already can see, in the denominator there is term z minus 2 whole cube. So then the only thing remaining is in the numerator, wherever the term z appears, we have to write that as z minus 2, since it is asked to write the Lorentz series expansion about the point z equal to 2. So for that, I'm just writing z minus 2. But since we are subtracting 2, so for that I'm just adding 2 extra to each term. Or firstly, since we can see z square is the common in each term in the numerator, so we can take that outside. So for that, I'm following this method. So I'm just taking z square outside, then we get z square plus z plus 1 divided by z minus 2 whole cube. So now by writing in terms of about the point z equal to 2, that as follows: z minus 2 plus 2 whole square, and in the remaining term similarly z minus 2 plus 2 whole square plus z minus 2 plus 2 plus 1. That is all about numerator. So in the denominator we have z minus 2 whole cube. So now from the numerator, by expanding the terms, we get z minus, this has z minus 2 whole square plus 4 times z minus 2 plus 4 into z minus 2 whole square plus 4 times z minus 2 plus 4 and z minus 2 plus 3 plus z minus 2 plus 3 divided by z minus 2 whole cube. So by just applying the simple arithmetical calculations, we can simplify this expression as z minus 2 whole square plus 4 times z minus 2 plus 4 into z minus 2 whole square plus 5 times z minus 2 plus 7 divided by z minus 2 whole cube. So from this we can easily get the coefficient of the term 1 divided by z minus 2. But since it is a competitive exams, and in competitive exams the time management is very important, but without doing the next step, one can easily calculate the coefficient of the term 1 divided by z minus 2 from this step only. Since in the denominator already z minus 2 whole cube term is there, so to calculate the term, the coefficient of the term 1 divided by z minus 2 whole square, it is just enough to look at the coefficient of the term z minus 2 in the denominator, sorry, in the numerator. When you look at the coefficient of the term z minus 2 in the numerator, since in the denominator z minus 3 whole z minus 2 whole square whole cube is already there, so if you can calculate the coefficient of this term, so we can easily look at the term a minus 2 from this expression. The whatever the coefficients are the terms remaining, that does not matter, since it is only asked the term a minus 2, that is nothing but the coefficient of the term z minus 2 whole power of minus 2. So it is just enough to look at the coefficient of the term z minus 2 in the numerator of this expression. To manage the time management in exams, that is a simple trick, but here I'll entirely show you the solution. So in total we get this as z minus 2 whole to the power of 4 plus 5 times z minus 2 whole cube plus 7 times z minus 2 whole square plus 4 times z minus 2 whole square plus 20 times z minus 2 whole square, sorry, 4 times z minus 2 whole cube and 20 times z minus 2 whole square plus 28 times z minus 2 plus 4 times z minus 2 whole square plus 5 times z minus 2, sorry, 20 times z minus 2 plus 28 and divided by z minus 2 whole cube, and in total this expression is yes z minus 2 whole to the power of 4 plus 9 times z minus 2 whole cube plus 31 times z minus 2 whole square plus 48 times z minus 2 plus 28 divided by z minus 2 whole cube. So now from this step we can easily see the coefficient of the term z minus 2, that is as 48. So without doing this step, since it is all does not need to calculate the terms z minus 2 power of 4 power of 3 power square and constant term, since it is asked to calculate the term, the coefficient of the term z minus 1 divided by z minus 2 whole square, and from this expression when you separate the denominator to each term, you can easily get the coefficient of the term 1 divided by z minus 2 whole square. And even without writing this step, you can easily calculate the coefficient of the term z minus 2 z minus 2 whole power of minus 2 from this step only. When you do that, you can save some time, which help you to solve some other problems. But here I'll show you the entire solution. So from this, we separate the divider to sorry, when you separate the divider to each term, you will get this as z minus 2 plus 9 times, sorry, plus 9 plus 31 divided by z minus 2 plus 48 divided by z minus 2 whole square plus 28. 28 times, or 28 divided by z minus 2 whole cube. This is the Lorentz series expansion of the given function f of z about the point z equal to 2. It is the Lorentz series expansion of f of z about the point z equal to 2. Hence, a minus 2, that is the coefficient of the term 1 divided by z minus 2 in the Lorentz series is given as 40 48. Here, the coefficient of z minus 2 whole square. And the answer is 48.